Hello students, in this video we will solve one example on modified Euler method. So modified Euler method is, if this is our differential equation dy by dx is equal to f of x y. So first we find yi0, this is a predicted value, and this we find by using Euler's method. So this is a predictor formula, and then by using this predicted value we find corrected value of yi. So yi1 represents first time corrected value, and we can continue this now because we got more accurate value of yi. So using this value of yi1 we will find second time corrected value. So yi2 is a more accurate value than this yi1 because we got more accurate value here. See here, while finding yi1 we are using yi0, so this is a predicted value, but now yi1 is corrected value. This is more approximate, more accurate answer, so this value will give you again even more accurate answer. So yi2, so this is second time corrected, and this is how we can continue this process until we get required stability in values of yi, and that we will call as yi. So that value, so for example r times repeated value of yi we will call as yi. So this r is depends on how much accuracy you want. Alright, so this is how modified Euler method works. Now let's have one example. So here we have to find approximate value of y where dy by dx is x plus y. So we will take simple example so that we can compare our answer with the analytic answer also. We have to find y at x is equal to n, and it is given that y0 is equal to 1. That means x0 is 0 and value of y at x is equal to 0 is 1. So this is what given here. So x0 is 0, y0 is 1. Function is x plus y. So first we will solve this using Euler method, not by modified Euler method. And then we will solve it using modified Euler method. So we can compare the answers. So by Euler's method, when you take h is equal to 0.5, so this is the answer y2, that is y at x is equal to 1. So we need two iterations. First iteration will get value of y at x is equal to 0.5, which is 1.5, and in second iteration we will get value of y at x is equal to 1, which is 2.5. This is by taking h is equal to 0.5. This is Euler method. Now suppose we take h is equal to 0.25, even smaller value of h. So for smaller value of h we get more approximate answer. So when h is equal to 0.25, so now there will be 4 iterations, and here y4, that is y at x is equal to 1, will be 2.8828. So you can see there is a difference between value of, here it is 2.5, here it is 2.8828. Now let us solve this using analytic method, and you can see here this is a solution. Y is equal to 2 into e raised to x minus x minus 1, and when you put x is equal to 1 you get answer as 3.4365. okay, so even these answers are not very close to this answer, but you can see when we take h is equal to 0.25 we get more low. So this is closer to this value, okay, than 2.5. So this is how Euler method works. Now let us solve same example using modified Euler method. Okay, so here same example, and we'll take h is equal to 0.5. So first we will find a predicted value of y1, that is this 1.5. So when x is equal to 0.5, value of y will be 1.5. This is a predicted value. Now we will correct this value. So this is our corrector formula. So this is the first time corrected value will be 1.75. So now this is a corrected value, first time corrected. We will again correct it. In place of yi0, now we will use yi1 and we will get yi2. So y12. This is second time corrected value of y1, and it is 1.8125. We will continue this process. Third time corrected value will be 1.8281. Then fourth time corrected value will be 1.8320, and now you can stop because you can see there is not much change. It is correct equal if up to first decimal place, so we can stop here. Okay, so now we'll call this y1 4. There is a fourth time corrected value of y1 as our y1. So y1 at x is equal to 0.5 will be 1.8320. Now using this value we will find y2, which will be y when x is equal to 1. So for that again we have to repeat same process. Now we will find predicted value of y2. So predicted value by Euler's theorem, it is 2.9980. Okay, now we will correct this value by using corrector formula. It is 3.4145 first corrected, then second corrected value will be 3.5186, third time corrected value will be 3.5446, and fourth time corrected will be 3.5512. Now we'll stop because we got answer correct up to almost one decimal place, and after that even these values are very close. Here we have 4, here we have 5, so you can stop here, and this is our answer. So y when x is equal to 1, y at x is equal to 1 is 3.5512. Now let's compare our results. So this is answer by analytic method, 3.4365636657. When we solve by using Euler method by taking h is equal to 0.5, answer is 2.5. But by modified Euler method it is 3.5512, and you can see we got very good answer actually. Even h is only 0.5, we got very good answer, 3.5512. By Euler's method, when you take h is equal to 0.25, answer is 2.8828. But by modified Euler's method, it is 3.4619. So this is how when we reduce value of h, we get more approximate answer. Now for this calculation, for h is equal to 0.25 and modified Euler method, it is not feasible to solve by hand. So we will solve it by using a Python program and we'll check our answer. So for that, let's go to this program here. So this is a Python program. First we will enter our function f of xy, which is x plus y. Then initial condition, that means the initial value of x is 0 and at x is equal to 0, y is 1. This is given. Let's enter value of x. So for which value of x we have to find y, so that is 1. Now we will enter h here. First let us go with 0.5. We already know what is the answer for 0.5, so we will check our answer also. For when we take h is equal to 0.5, there will be 2 iterations, and you can see here is the answer. Value of y at x is equal to 1 will be 3.5512. Okay, which is same as our answer. It is 3.5512. Now let us do it for h is equal to 0.25. So we will change this value of h, 0.25. So there will be 4 iterations now, and we can see, so these are so these 4 iterations are there, and the answer is this 3.4619, which is this 3.4619. So we get more approximate answer. Now what we'll do, let's change this again, reduce this value of h. Let's see what happens when you take h is equal to 0.1. Now this should give us again more correct answer. So there will be 10 iterations because we are taking h is equal to 0.1. So these are the 10 iterations, and here is the value of y at x is equal to 1 is 3.44045, and you can see this answer is very close to this answer. So this is how value of h, for a smaller value of h we get more approximate answer, and this is how Euler method works. Thank you.